Hello. The following example is example 4.1.7 from your notes. In this example, we are going to actually find the inverse functions when we're given equations. Now, there are a few steps that we're going to take here, but before we do that, we have to realize only functions that are one-to-one can even have inverses. Now, notice that f of x equals 2x plus 5. Its degree is odd. Therefore, its end behavior, it's going down to the left and up to the right. This is possible for it to be one-to-one. For letter B, y equals x squared plus 2, this degree is 2. So it's going up to the left and up to the right. Therefore, no matter what happens, this will always not be one-to-one. Therefore, this cannot even have an inverse. C, f of x equals x minus 2 cubed. This degree is 3. Therefore, as you're going to the left, you're going down, and as you're going to the right, you're going up again. Hopefully by now you're realizing only odd degree polynomials even have a chance of being one-to-one. Every even degree polynomial function is not one-to-one, which means they do not have inverses. Now, there are a few steps that we're going to take in order to find these inverses. We want to figure out if they're one-to-one, but we're going to figure out if they're one-to-one by seeing if they have an inverse. Therefore, if they have an inverse, they are one-to-one. So let's look at A. The first step in solving these is change f of x to y. So f of x is actually y, so y equals 2x plus 5. Now, at this point, I'm going to draw a line. And the reason I'm going to draw a line is because everything from here on out is going to actually be the inverse function, if it exists. The second step is to change all x's to y and all y's to x. Therefore, this y becomes an x, and this x becomes a y. The third step will be to solve for y. So this is the equation I'm going to solve for y with. The first thing I'm going to do is subtract 5 from both sides. That gives me x minus 5 is equal to 2y. At this point, divide both sides by 2. I'm actually going to leave it as x minus 5 all over 2. That gives me the inverse function, f inverse of x is equal to x minus 5 all over 2. I kind of skipped over the fourth step here. The fourth step is to change y into f inverse of x. Now this is pronounced f inverse of x. In other words, that -1 just means inverse. So the solution here is that f of x equals 2x plus 5 has the inverse function f inverse of x equals x minus 5 all over 2. Because it has an inverse, that means that it is one-to-one. Let's look at letter C. Following these steps again, change f of x to y. So y equals x minus 2 cubed. Draw your line. Make x equal to y minus 2 cubed. Now solve for y. Notice that everything over here is being cubed. You can only do this whenever everything on one side is being cubed. What I'm going to do now is I'm going to take the cube root of both sides. That means that the left-hand side becomes the cube root of x, and the right-hand side is just y minus 2. Then you add 2 to both sides. When you do that, you get the cube root of x plus 2 equals y. Now notice that this plus 2 is outside of this radical. You have to be very clear with that. Do not try and fudge and make the radical go to halfway into the plus to make me guess whether it should be inside or outside the radical. If I have to guess, I'm going to guess that you did not know and count it wrong. So be careful with it. The last step is to change y into f inverse of x. So that's going to be the cube root of x plus 2.